ever wondered how a series of just still images combine together to make a moving picture? Is it something that happens in our eyes, or is it something that happens in our brain? How is it we see motion? And how do things like stop animation work? Oh, hello! This is my new mascot, Dr. McScience.
Hello!
And she is the star of my new intro scene.
Hello!
Oh dear, looks like she's got quite a lot to learn in her lab. Hopefully Dr. McScience will join us in future episodes. But anyway, why is it when you put a series of still images together, we stop seeing flashes of those images and start seeing smooth motion? Well, historically, scientists have put it down to persistence of vision. This is a physiological phenomenon, part of how our eyes work. But really, a lot of how we perceive motion is how our brains analyse what our eyes see. But let's start with the historical thought, persistence of vision. Now I want to test this out with a little bit of an optical illusion. Look straight at the centre of this screen and try not to move your eyes or blink too much. Now when I remove the image, what do you see? Scotland! So this persistence of vision effect actually comes from the light detecting cells in our eyes turning up or down their sensitivity, depending on how bright the thing is you're looking at. These changes to sensitivity build up over time and have a bit of a delay on them, which means that you can sometimes see the image seconds or even a minute after the image that you're looking at is gone. So probably you're not seeing the Scotland flag anymore, which is a real shame. So I'll leave some of the best bits of Scottish Twitter on the screen for you to enjoy. So we've known that flashes of images in quick series cause the illusion of motion for hundreds of years. But it wasn't until the 1920s that we started to realise that it wasn't because of this persistence of vision. In fact, most of what we see as motion can really come down to how our brains analyse what our eyes see. We like to think of our eye as a camera. We look at an image, the light comes into our eye, hits our retina and sends that signal to the brain. But in fact, things are a lot more complicated than that. Try looking at yourself in a mirror and catching your eyes moving from side to side. You can't do it. Even though our eyes are looking in one direction, sweeping across and then looking in the other, our brain backfills that as two separate images and doesn't detect our eyes moving. So our brains are constantly filling in the blanks. It's taking two separate things that our two eyes are seeing and putting those two images together to make a 3D image of the world that's moving and in motion. So if you get a series of images that are changing fast enough, say more than 10 times in a second, our brain reduces all that information into a simple moving image that we can comprehend more easily. This is called beta movement, because while the actual image that we're looking at isn't physically moving, to us it appears like it is. In all honesty, our brains are pretty easily tricked, which is why optical illusions are such a thing and why animation even works. I find animation really fascinating and I'm hoping to do more science on animated films. So if you have a favourite animated movie, leave it in the comment section down below and I might try and analyse some scenes from it or talk about the animation process or something like that. And in other exciting news, my super nerdy boyfriend and I are going to be hosting a podcast together. We're going to be answering sciencey questions from yourselves, from viewers, from listeners, and it's going to be super fun, quite conversational, very light. So if you're interested in that, leave your questions down below and we'll definitely get to answering them in our podcast. So stay tuned. It's going to be hosted on this channel and also I'll share the podcast link via Twitter and all those sort of things. So make sure you follow me on social media and stay tuned for that because it's pretty exciting. Anyway, I hope you enjoyed this episode of Science with Steph. If you did, be sure to give it a like and share it with your friends. I bring out new videos every week, but in the meantime, if you want to watch my last episode, you can click here, or if you want to watch the video that the YouTube algorithm thinks that you enjoy best, you can click down here. Alright, thanks for watching, see you, bye! Scotland, Scotland.